Good afternoon, everyone. I'm Amma Maheshwari, Assistant Professor, Department of Electronics and Communication Engineering. In this particular video, I'm going to explain about adaptive equalization. The necessity for this is most of the channels here are made up of an individual links. For example, in the switched telephone network, the distortion induced depends upon mainly two things. One is the transmission characteristics of individual links, and another one is number of links in the connection. Hence, the fixed pair of transmit and receive filters will not serve the equalization problem completely. So in order to restrict this, the transmission characteristics of the channel keeps on going. Hence, here the adaptive equalization is used. The main principle is the filters adapt themselves to the dispersive effects of the channel. That is, the coefficients of the filters are changed continuously according to the received data. The filter coefficients are changed in such a way that the distortion in the data is reduced. There are two types of adaptive equalization. One is pre-channel equalization and another one is post-channel. In pre-channel equalization, if an equalization is done at the transmitting end, will be called it as a pre-channel equalization. So, this type requires feedback to know the amount of distortion in the received data. Then in the post channel, the equalization which is done at the receiving end will be called it as a post channel equalization. Here no feedback is required. The equalizer is placed at the receiving filter in the receiver. This is the structure of a adaptive equalizer. First, we are giving a sampled input signal xn of t to the timer, that is delay, where continuously we'll be following xn of t and x2n of t up to xn of t likewise. Then we'll be using variable weights w0, w1, w2 up to wm minus 1. Then the desired response dn of t is being given to the summer, and finally we'll get an error e into n of t signal. So the adaptive equalizer shown in the figure above is a tapped delay line filter. It consists of a set of delay elements and variable multipliers. The sequence xn of t is applied to the input of the adaptive filter. The output yn of t of the adaptive filter will be this equation. Here the weights wi and the taps are basically adaptive filter coefficients. A known sequence is transmitted first, that is dn of t is transmitted first. Then this sequence is known to the receiver. The response sequence yn of t is observed. As shown in the figure here, the error sequence between the two sequences is calculated, that is e into n of t equal to d into nt minus y into n of t. Here note that if there is no distortion in the channel, then d into n of t and y into n of t will exactly same, producing zero error sequence. Then the weights of the filter wi are changed recursively such that error e into n of t is minimized. These are the standard algorithms to change the weights of the filter recursively. There are two operating modes of adaptive equalizers. One is a training mode and another one is a decision directed. That is, the input is given to the adaptive filter and then to the decision device, and finally switch will be there. Will analyze the data using the training sequence. In training mode, when the switch 1 is in the position 2, training sequence is applied to the equalizer. So when the training sequence is basically the maximal length pseudo noise sequence, it generates the synchronized version in the receiver. The training mode sets the coefficients of the adaptive filter. Decision directed mode. Here, when the switch 1 is in the position 1 after the completion of training mode, an error signal is given as E of nt equal to B of nt minus Y of nt. Here B of nt is correct estimate of the transmitted symbol. Y of nt is output of the adaptive equalizer. Adaptive filter coefficients are adjusted continuously such that error signal E of nt is minimized. Thus, in decision directed mode, the adaptive equalizer tracks so value then the channel characteristics. Least mean square algorithm, which is used to change the tap weights of the adaptive filter recursively. The tap weights are adapted by this algorithm as follows. where WIN of t plus t will be called as a present estimate for tab I. Then the updated estimate where mu is nothing but the adoption constant. In this algorithm, initial tab weights are assumed 0. The assessment are define adaptive equalization and what are the various types of adaptive equalization, and particularly what is the use of decision directed mode. Thank you.